So as I said at the start of this session, it's fantastic that it's such a diverse range of people who are working in manufacturing, and it really spans effectively all sectors and all disciplines. Our next speaker is going to give us somewhat of a more, I guess, industry academia blur, if I'm correct in describing it that way. So someone who's really looking towards what is the next step in manufacturing. And this person, Jose, is going to talk to us a lot about some of the innovations that are going to spur the next round of industries that we've just heard so much about from our keynote speaker. So I'll let you take the floor, and let's welcome him.
All right, you can hear me okay, right? It's after lunch, we're a little tired, we're a little sleepy. So I'm gonna take a poll just so you can raise your hand and get the blood flowing. How many of you are students? Keep your hands up. How many of you that have the hands up are going to be entrepreneurs? Great. How many of you are already entrepreneurs? Okay. Of the non-students, how many are entrepreneurs? You started a company. Keep your hands up. How many of you are investors as well? How many have invested in a crowdfunding type of activity? Okay, a couple. All right. How many professionals that are not entrepreneurs? All right. How many academics? Fellow academics, a few. All right. Who did I miss? Any anthropologists? Historians? Those are my favorite. Economists. Yeah, thank you. This is the new world. Anyone, even without an engineering degree, can participate in the democratization of manufacturing, right? And so when I was asked to speak about scaling up, and given the history of this organization, I thought, okay, these are entrepreneurs, these are professionals, these are academics and entrepreneurs. I probably forgot to ask, how many academics that are entrepreneurs are here? One, okay, sort of, half. Okay, and I said, okay, let's not just talk about the manufacturing, but let's make some assumptions. One of the assumptions is that technology works, okay. The first assumption I'm going to make is that you're following some kind of process, right? When Q-Tech was started 12 years ago, this is all we were talking about is how do you get started? There's so many now books out there. I'm a little biased. One of my colleagues wrote a book. Bill Aulett runs the Entrepreneurship Center at MIT, wrote this book, Discipline Entrepreneurship. I think it's great. It's the next big thing. But there's so many others, right? The Lean Startup, 4 Steps to the Epiphany, you name it, user-driven innovation. So one of the things I'm assuming, because there's no excuse for not doing this, is that you're following some kind of process to develop your technology if you're an entrepreneur, to develop your startup, okay? Don't make the mistake of not doing it. They're all good. The second is that if you start looking at all of these processes, all these roadmaps, all these books, there's a lot of questions about how to grow your company, right? This is actually, again, from my colleague, from Bill, and these are some of the questions that he asks entrepreneurs, and you can see they're pretty interesting. But how do you scale your business? Look at the questions. How do you finance your business, and how will you grow? Right? There's nothing in there about production. Most of these books assume production. It's kind of interesting. Assume you will scale up. Assume you will ship this to China. Assume you will produce it here. They just assume. Very few actually talk about it. And that's what I want to talk about in the second part of my presentation. I'm also going to assume that you haven't made the mistake of trying to be a lone entrepreneur. There's no excuse for it. You've got to get a team, right? So you need someone that's going to be the connector and the fundraiser, someone that's a domain expert, a production specialist, the beaver, which is the MIT mascot, Someone that knows operations and distribution. I think that's very important. Someone that's a sales enthusiast. We always forget about sales, especially if you're a scientific entrepreneur. And of course, your advisory group. This is kind of standard. I think something that's new is you also need a design genius in your team nowadays. That's part of what advanced manufacturing is. It's design, production, and distribution. Right? So I'm assuming you've developed a team. I'm also assuming that if you need to make something, you need to produce something, you figured out that there's lots of services out there to connect you to a production ecosystem. Right? This is an accelerator in Boston, Somerville, which is a town over. Greentown Labs, started by 3 entrepreneurs in the clean energy space, and they provide facility equipment software and connectivity to a production space. They actually have, it's basically a makerspace before there were such things as makerspace. So this is about 10 years old. Right? All about clean energy. They're doing great. Or if you're just a general hardware startup, you find someone like Bolt. They de-risk manufacturing, and they're an investor. It's a different type of investor. Which brings me to this. I'm also assuming you're not expecting to just get venture capital. There's so many ways of getting funding right now. Apart from these accelerators, I was just in Barcelona yesterday. I flew in this morning on Ryanair. It was quite an experience, my first time on Ryanair. Anyone here from Ryanair? Okay, I won't say much then, because I'm being recorded too. These were the crowdfunding platforms we found in Barcelona just yesterday. Right? Money's there. Right? In the US, it's also expanding and changing. Right? But now, it's not just about your investors and accelerators. With the crowdfunding platforms, you now have a greater base of accredited investors. Your lawyers and accountants are also investing, taking equity. Right? You almost can basically start a company without getting investment in the traditional sense of cash. Right? So those are my assumptions. Right? Because if you've made any of these mistakes, go home and correct them. Get a team, find an ecosystem connector, right? Find other types of equity. Right? That's the first half. But what you came here to learn about, I think, is, okay, so let's not assume production. What is going to change the way we're going to produce things in the future? Everyone's talking about additive manufacturing, 3D printing. Right? Dirty little secret of 3D printing. And let me tell you, I love 3D printing or additive manufacturing. But the dirty little secret, it's massively unsustainable. Many of the things that are printed are actually not recyclable. Much of the energy, especially when you look at the larger machines, take a lot of energy. Right? It's surprising how expensive and how big some machines you need in order to produce the smallest things. It seems that the smaller you need to produce something, the bigger the machine and the much more energy it requires, right? Especially for production. So yes, it's a great educational prototyping tool. Right? It's actually changing the perception and reality of manufacturing. You are seeing some very large machines. Many of you are probably familiar with the smaller machines, $5,000 and less, usually print in plastic of some sort. How many here have worked with a laser sinterer? One, okay. So they actually print in metal, right? But they take a lot of energy, don't they? And it's basically a powder that's being melted. And so you have lots of waste, actually, that powder, and you don't want to be around it. It's highly toxic, actually. Right? And so you have these machines that are multi-million dollars that are being used for production. but not for mass production. It's not a mass production technology. All right. So what are the three technologies to keep abreast of that I think are not only going to change, democratize, and make production more sustainable, but also going to enable many more startups. All those startups we've heard about today, the startups that you are creating, are going to be possible because of these technologies. The first is around CAD. How many here have used AutoCAD? How many have used AutoCAD in the cloud? Did it work? Sort of, yeah. This is a company that is actually founded, just came out of stealth mode. It was founded by the, I guess he's always been the founder, but now he's the ex-founder because he left the company, of AutoCAD. Right. And it's CAD on the cloud. It's called Onshape. Came out of stealth mode about 2 months ago. And the expectation of designers, of production people, is that you can now develop your designs on the cloud and it's going to be accessible through any platform, including the mobile platform. That's been very difficult to do. Right? And it's also very difficult to share files across the world, especially when they're massive files, hundreds of megabytes or gigabytes. If you make a change here, it'll be automatically logged and shared across the world instantaneously. And it updates a production the production plan as well. That's revolutionary. We're also going to assume that most of the now production companies are automated in some way. This is another company that was started by an MIT alum, Mick Mounds, bought by Amazon. Anyone know Kiva Systems here? Essentially, they're robots for the warehouse in a distribution house. There's lots of other companies that are doing this for manufacturing warehouses. The next evolution for them is actually moving the work in progress, or the work that's being worked on, the materials worked on, across the manufacturing plant. Right? You put those two things together, and then you have a company like Protomold. Anyone here has used Protomold? Okay, a couple. So you can actually order some injection molded parts. About 25 is the minimum, right? You can get them, if you pay a little extra, within a couple days. It's amazing. This is injection molding made possible by additive manufacturing, right? And by essentially a CAD system on the cloud. It's awesome, right? And then you have the distribution. It's already kind of been solved, actually. Amazon's been working on this for a while because of the e-tailing. Etsy just manufacturing at the small scale. So you've got, okay, production, you've got design, and then now you've got distribution. So this is the first technology, I would say, is the beginning of what we actually have as the production cloud. Think of, well, some of you actually don't remember 15 years ago, but those of you that do, think of when you were starting a web company, you assumed you were going to not buy any infrastructure, right? You weren't going to buy the servers anymore, and you assume that now. If you're going to start a web company, you essentially use the cloud for pretty much everything. For your mailing lists, right, to your database, to your event planning, you name it. You can start a web company pretty easily. The second innovation that I think is going to change the world of production and allow scale up and make it more sustainable is bio. Microorganisms, they scale up naturally. It's actually, when I saw this, this graphic many years ago, I realized why it's so important to wash your hands frequently. These are bacteria, and you basically get 1 billion bacterial cells on your hands from just one, within a couple hours. There's a company already. Actually, there's a whole, any synthetic biologists here? One, excellent, all right. The manufacturing plant of the second half of the 21st century is going to be the bacterial cell. And I know that because it's already happening. There's a company that started out of MIT, some former classmates, called Gingo Bioworks, and they're already working on specialty chemicals and materials. Right? They just got I think it was a $10 million grant to work on some projects for DARPA, our defense department in the US. Right? But they're doing a lot more than that. This is probably one of the companies, and in the future we'll think of the Microsoft or the Apple of the industry. They're developing the operating system and the tools to be able to use microorganisms for production. One of the kind of interesting things about this is also that it takes a lot less energy, right? And we start thinking about water and a few chemicals as the raw material. That's the amazing thing about the biological cell. It's a whole production system already ready to go. If we're responsible in the way we develop it, it can be amazing. The third and last technology that I think is really going to change everything, in combination with the other two, is roll-to-roll manufacturing, continuous manufacturing, and micro-contact printing. Micro-contact printing is basically printing really small lines on a sheet. Now, if you can do that in a continuous fashion, think of newspapers. That's basically what it is. But really small, you can create some very interesting things. So here you have the concept of a roll. It's printing on something that's going by, and we've done some research. My colleague at MIT, Professor David Hart, has actually done a lot of work on this roll-to-roll micro-contact printing. And it's been in research, but now you can actually, this is amazing, you can go out and buy, very soon, a machine that allows you to print on roll-to-roll organic photovoltaic cells. This is incredible. So who asked the question about flexible electronics? This is it.
It's available in gaming as well.
That's right. And I'm going to talk about a company available in gaming. It's one of them, absolutely. So this not only enables flexible electronics photovoltaics, but because you can print any structure, any pattern, you can now have anti-fouling surfaces, for example. We've tried some of these. Different types of batteries. We've tried some of these, right? Porous or selective membranes, so desalination is another way, right? It's interesting. These are the technologies that are bringing down the cost of mass production, right? And there's another company. How many know this company? Okay, right? And I was curious. So they just received a round of, I think, about $8 million to develop flexible electronics. Anybody work with them, actually? Anybody know them? You do? Are you working with them now, or are you?
Yeah, we are.
Excellent. So they're 20 minutes away, right? I thought that was very cool. I think I'm going to hop on a taxi and go find them. Hopefully they're open. But it's already happening, right? It's not like this is the future. These are the tools that are being used right now to develop new products for the startups that everyone's talking about, right? And if you develop more around these tools, these are what I would call the shovels of the next gold rush, right? If you can work and develop in these areas, you're going to make lots and lots of pounds, right? But you're also going to enable something else more interesting. I mentioned one of the problems of additive manufacturing and of the new materials that we have is they're usually not recyclable, right? If you can use sheets, essentially, that you're able to separate to do your additive manufacturing, you might be able to separate materials. And that's one of the hardest problems for, in recycling, is separating materials, right? There's a company that's trying to do that so that you're able to separate the materials for recycling appropriately. That's kind of cool, right? I think that'll be sustainable. That is a game changer, right? But then you start combining these three, and the possibilities are endless. Here's a water filter that's actually a cell, and it's being printed. It's a living cell. It's being printed, or hope to be printed very soon, Rolltoroll. Okay, that's cool. But I want to come a little bit closer to home. So Q-Tech was started about 12 years ago. And when it was getting started, I got to know some of the early presidents. And in 2007, Salvatore Mafia, I think in 2008, received his doctorate from here in chemical engineering. He went over to MIT to do a postdoc and worked with us for about 5 years on continuous manufacturing of pharmaceuticals. He actually started a company 2 years ago, exactly that. So I thought, oh, geez, it's going to be really hard and really difficult to talk about highly regulated industries where these technologies are going to be applicable. No, actually, Sal's proved me wrong. He's already doing it. And they're up in pilot plant in the other Cambridge, actually near the other Cambridge. And it allows the production of small amounts of pharmaceuticals. Think clinical trials. Right now, one of the big problems is you have to make the same batch, make a big batch for your clinical trial, even though you might need a small amount. And then scale up is the big problem for regulation. You actually need to have the same manufacturing process as you have for your clinical trials. This is a continuously scalable technology. So the small amount, and it's been pre-approved by the FDA, a regulatory agency, Food and Drug Administration in the US, for a scale-up. That's very cool. And it's not only revolutionizing the production, but also the education field. This is a company, actually, that just received a few $1 million, about $40 million. And their product, if you will, are essentially prototyping workshops using smart Legos. And now they're expanding. They started off in the school system. Now they're expanding into the corporate world. And that's why several venture capitalists have invested in them, $45 million, right? And you start to hear these stories. In stories you used to hear only in the web and the IT space. Can you start a company with $0 or zero cash, 0 pounds? I think we're beginning to see some companies that would be able to do that in the hardware space. So with that, I want to say thank you. It's been a pleasure being here, and it's quite exciting to be with you guys.
We're doing very well for time. Thank you, Jose, for keeping us to time. If anyone would like to ask kind of a burning question, nothing seems to be coming through. Okay, one question perhaps?
Right, okay. So I guess I think about it a bit differently. I think instead of mass manufacturing, let's say at a set number of sites, it might be smaller amounts, but distributed all around the world, so kind of mass decentralization of production.
Yeah, so a couple things around that. When you start looking at mass production, so that is, you need to produce the exact same item or some variation of the same item. Any manufacturing engineers here? You now know you need to start getting into repeatability, into accuracy, into control processes, right? And we still haven't developed the technologies to be able to do that well in a distributed system. I think there's some people working on it. Are you guys working on it? Is anybody, you know anybody that is? Yeah. Yeah, so the basic fundamentals of what we call mass manufacturing, right? Systems engineering, quality control, all the tools that go along with that haven't been applied to 3D printing or additive manufacturing in general, even for the very large machines, you know, the multi-million-dollar machines. So yes, that will be the future, but that's probably the future. I was about to say 15 years from now, but given exponential, let's say 5 years from now, or 3. And I think what you are now producing are kind of these rough prototypes. So it's great for prototyping, right? For mass production, not quite there yet.
Thank you.
Superb. I think we'll leave the rest of the questions to the panel session. Let's thank our speaker once again.